So I work for Flexware Innovation. Flexware Innovation is a systems integrator based out of Fishers, Indiana. We primarily specialize in software integration. So we've got about 250 employees. Over 200 of those are engineers working on delivering products and services for primarily our industrial clients. We've been doing it for almost 30 years, so it's kind of our passion. So today I want to talk about the concept of middleware, and especially how middleware can add value to your AMR projects and your overall intralogistics operations. And I want to quickly kind of go through a definition of what middleware is, why we think you need middleware if you're implementing AMRs, and then finally, how can we increase ROI by the use of middleware? And there's some key factors to key in on there. So I'm going to crank through it. I got a lot of content here. I don't know if we're going to have time for questions, but if we do, I'll take some questions. Otherwise, we do have a booth here. We'd be happy to have a conversation with you after this as well. But let's start with what is middleware. So any good product manager will tell you that before you define a product category, you got to define what the problem space is. So let's start with a little bit of a definition of what the problem space is that middleware is defined to be able to meet. So it kind of comes in two areas. One is the processes involved, and the second thing is the systems that are involved. So let's start with the processes. So we all know intralogistics processes are complex. We're moving lots of different things around the facility, all different shapes and sizes. We've got raw materials that come in one form, get transformed, go out the door in another form. So there's a lot of different types of vehicles we're going to need to be able to move that stuff around. The locations where we're dropping this stuff and picking this stuff from also is varied. We've got anywhere from high bay storage areas to complex floor Kanban areas to equipment that we need to be able to communicate with and drop things into and pick things from. So there's a lot of variance there as well. And the thing that I really want to key on here is the fact that in these processes, you have all this continuous decision making and exception handling that's going on. So what are we talking about here? We're talking about automating intralogistics. So if we're going to be automating these processes, we have to be able to most likely replace something that's being done right now by humans. And humans are able to process things very quickly, be able to make decisions on the fly. Lots of experiences built up within algorithms they can process. So we have to be able to duplicate that and probably even go beyond that if we're going to fully automate these things. Otherwise, we're going to still have humans involved, and that's going to cut down on our ROI. So all of this kind of leads to the systems that we've got in place, and there's some complexity there as well. So very few companies are going to be able to say we're just going to snap our fingers and instantly be able to automate everything across our intralogistics process. So most likely you're going to take a very pragmatic approach. You're going to start small, you're going to build up, and so you're going to get this wide spectrum of systems that you have inside your four walls, everything from legacy manual systems to emerging technology and modern software, and all of that stuff has to coexist together. And if we take a look at systems in a slightly different way, if you kind of plop all your systems down on a pane of glass, give them names, and start to talk about the patterns that exist between them, it's a little bit chaotic. So there's lots of, we said, emerging technologies here. There's a mixture of manual systems, automated systems. Most of these systems are inherently disconnected, but they can't be that way if we're going to automate everything. So when we start to look at the intersection of our processes and our systems, you start to understand that there needs to be this connection between all of these different systems that are involved to execute your processes. So we're looking at one simple process here, a put-away process, and there's 6 or 7 different systems that you might need to integrate with in order to be able to execute that. So connectivity is very important here. All these systems have to be able to talk to each other if you're going to automate that entire process. And there's a control flow here. There's a sequence in which you need to be able to execute all these process steps in the systems. So you need something that's going to be able to handle that control flow for you. And all these things have to share information with each other because most likely you've got data coming in at the start of the process, you've got data coming out at the end of the process, and you need to be able to pass that along the chain as you go. And as you add more processes on top of your systems, it gets even more chaotic and complex. So here we start to see that some of your systems are being shared between your different processes, but they may not have the same behavior on your different processes. So this is where we start to introduce the concept of how middleware can help. So in this case, middleware is kind of representing all these different connectivity points that exist between your systems. So we're circling back around now to the definition of middleware. So when we talk about middleware, we're talking about software, and we're talking about software that helps you be able to connect otherwise disconnected systems together. There's a couple of core attributes for middleware. One, it can connect systems together. The other thing, it helps facilitate communication between those systems. But in our minds, middleware probably needs to do more than that. And advanced middleware can do a lot more than that, and that's where you can start to achieve more of your ROI. So this is a model that we like to use at Flexware to start conversations with companies. It's taking all of those systems that we talked about earlier and the processes, and it's interlaying them together into a form that can be a conversation starter and then a reference point as we have conversations moving forward. So it helps to start to bring some organization to the chaos that exists. So you've got your systems represented as your rows of this hierarchy, and this is kind of borrowing from the ISA 95 model. So you got all your control level stuff down at the lower level, and then as you build up, you're starting to get into more higher level systems, and then finally you get to your ERP and your business systems at the top. Across the columns of this model, you have all your different process areas, and you can start to draw some correlations. Obviously, there's gaps that exist, there's chasms that exist in between your systems, and we want to be able to try to close those gaps as we go forward. So how can middleware help? Well, a lot of times we talk about middleware connecting our higher level systems with our lower level systems. So that's what this represents here, but again, I want to take this a little bit further than that and start talking about how middleware can start to unify all of your processes and your systems together, and that is where the real value lies. So let's talk a little bit about why you need middleware, and I want to focus on a couple of misunderstandings that we've heard as we have conversations with companies that are embarking upon their AMR journey. And sometimes these misunderstandings can lead to bad decisions and can lead to some regrets. So the first one of those is this myth that we like to refer to as API equals done. And very simply, when we talk about API here, application programming interface. So most modern software has an API, and it's just a definition or a specification that dictates how you're going to interface to those systems and how you're going to get information into and out of those systems. And most APIs, they're unique to whatever system you're talking about, but they're required. They're required to be able to communicate to those systems. But the presence of an API does not mean that you're done. So let's use a little bit of a hypothetical here. So in this case, we're talking about a very simple connection between a warehouse management system and a fleet management system. This is a typical starting point when you talk about integration. And you're going to do your due diligence as a company. You're going to go to your AMR supplier. You're going to ask them, hey, can you communicate with this warehouse management system? And I guarantee you the answer is going to be yes. And they're going to say something like, well, we have an API. And in fact, because we have an API, we can talk to anything. You're like, okay, cool. So then you go to your WMS provider and you say, can you talk to this fleet management system? And their answer is going to be exactly the same. Yeah, we can do it. We've got an API. We can talk to anything. So you're going to be tempted to think, okay, I'm done because I have two APIs that allow me to be able to communicate with those systems. But the fact of the matter is, that's kind of where it starts, not where it ends. And I'm going to use a very simple illustration here that we can all relate to kind of drive that point home. So in this case, I'm talking about a couple systems that we all understand. You got a simple power receptacle and you got a laptop computer. And we all know you got to get power from that receptacle to that laptop in order to turn that laptop on and have it function for you. So you can ask yourself, do I have an API in this case for each of my systems? And the answer is, yeah, it's a hardware API, so it's a little bit different, but I think the illustration holds here. So on the power receptacle side, you've got a connector type. It's a 2 or 3 prong plug that I need to connect into. It supplies a voltage, 120 volts, and it has a type of current. In this case, alternating current comes out. So I'm like, okay, I know how to get power out of my receptacle. Now, what about my laptop? Well, I look at the laptop specifications, and it has a connector type. In this case, it needs a USB-C connector in order to be able to connect. In this case, it needs just 20 volts of voltage, and it has to be direct current type. So you're tempted to think, okay, I've got 2 APIs. Am I done? Well, obviously, we're not done here. You need something in the middle that's going to connect those two systems together into the APIs and handle the things that you need done in the middle. So a couple things here to key on. So when it comes to this illustration, you have connectivity. So you have this ability to connect, built-in connectors for each of your sides of your system. You've got some intelligence in the middle, the power adapter in the middle. It's doing your voltage transformation for you, doing your current transformation, and all of that is handled for you. And then finally, it's simple to use. I know how to plug it in. We all know how to plug it in. We know it's a snap, and in 5 seconds, we're up and running, and we're moving on with value-added work. And we don't have to have engineering degrees to understand the science behind how the voltage and current transformation is working. It just works. We know it works. We trust it, and we're moving on. So if we go back to our software example, it's very similar. So you still need something in the middle, even if you have two APIs. And that something in the middle is what we would call middleware. And there's a couple core things we know it does. We know it connects. We know it facilitates communication between the two systems. But our point is it can do so much more. So it can start to handle protocol conversions between your systems. It can do entity translations. Let's take the concept of a location. Each of these two systems knows what the locations are in their systems, but they may use different IDs and codes from one another. So your middleware can help translate those locations between the two systems. And you can start to introduce advanced business logic and decision making, because going back to our illustration about the human-centric operations that we're trying to automate, you need something that's going to be able to start to make some decisions and handle faults in order to keep your system running. And that's the point here, is to keep things running and not have any downtime. And then the last thing, probably the most important thing, it needs to be super simple. Everyone needs to be able to open it up and with a few clicks of the button, configure the software, and have it do what it needs to do, and not have to possess computer science degrees or software engineering degrees. Even though we are implementing a programming interface, we don't have to be programmers in order to make it work. You want to be able to, you want it to work the way that you work, and you want to be able to get on with the rest of your job. Okay, so the second sort of myth is companies will be tempted to think that the AMR supplier is going to handle their integration. And this makes sense. We all kind of want the one butt to kick mentality, right? So you want one organization to be able to handle everything. So you're going to be tempted to want your supplier to be able to handle your integration for you. But most of these suppliers are not really set up to be able to handle the advanced software integration. So we're looking here at kind of the 4 categories of AMR suppliers that are out there. You've got your typical OEMs that are focused mainly just on hardware. Now, obviously, there's software running on the robots, but they're all about the robots, the control of the robots. They may have some fleet management software that they developed as well, but they're typically not staffed for advanced integration and a lot of services involved to do complex custom integration out into the rest of your ecosystem. Now, you got full service OEMs down there to the left as well. Now, in this case, they are built to be able to handle end-to-end integrations, and they want to do so. But they're going to use middleware that is their middleware that works the way that they do, and it's going to be kind of black box, and it's going to do only what you need to do for that particular project. So scalability is a concern there, and most likely, if you need to make any changes moving forward, you're going back to that supplier, and there's change orders involved in order to make those changes. So it's very hard for you to scale that moving forward. Moving up into the integrator. So there's a lot of integrators now kind of building up in this space that are also going to be able to sell vehicles. And they're, again, more hardware focused. They're focused on attachments, fabricating, handling units for you, working with equipment handoffs, very hardware centric. And if you ask them to do an integration, they may do it, but they may not be staffed to really do it to the sophistication level that you're going to need. And they're going to use whatever skill sets they have, which most likely are going to be kind of lower level, kind of at that PLC or control layer. So very hard to scale that, very hard to make changes moving forward, and most likely going to have some difficulty when it comes to communicating with some of your higher level systems. And finally, you've got just straight up distributors, and of course, they're just selling the hardware, and they typically don't have any staff to be able to handle services for integration. Okay, so now that we've kind of settled on the fact that we need middleware and understand what middleware is, how can we take it to the next step and have it start adding more value to our projects? So let's kind of just level set. When it comes to ROI, it's all about reducing cost. And there's really two ways you can go about reducing that cost. You can reduce the upfront implementation cost. Typically, that's a capital program that you're executing. And obviously, the way to do that is you're going to do it faster and you're going to do it with less services. So as a little bit of a frame of reference, our market research has indicated that for a typical AMR project, you're going to spend 25 to 30% of your overall cost on integration. So if we can get that number down, or like 15 to 20%, you've got some margin there to work with to help with your overall ROI. The other ongoing cost and support, or OpEx related stuff, this is your operational cost that you're going to incur over the life of that system. In this case, what we're trying to do is we're looking at automating as much of the process as possible. Again, we want to reduce drive the cost of that human intervention out of the project as much as possible. And there's a couple ways to do that. So you want to reduce the time it takes to manage and scale your solution. So again, back to that simplicity factor. You want to be able to quickly be able to test new things, roll it out, try it, roll it back if it's not working, and move forward as you go. You don't want to have to get a lot of entities involved. You don't want to have to spend a lot of time doing that. And the other thing is reducing downtime. Downtime equals money. So we want this system to be smart enough that it's handling exceptions as they occur, hopefully automating the way around that. And in the case of when a fault has to be raised and you do have downtime, let's get the notifications out to the right people and let's get the right information out about the real root cause of that problem. If we can manage all of that, we're going to, again, eliminate the amount of time and resources it costs to maintain the system moving forward. So that's the goal of what we're trying to do here with middleware. So let's talk about a simple use case that hopefully will kind of drive that point home. So most companies start kind of small. They're very practical about how they get into the world of AMRs. And they'll take a very simple use case, and it's typically called the crawl, walk, run approach. And so for our hypothetical use case, let's consider a simple material replenishment. So we're a manufacturer, we've got a manufacturing cell. It requires raw materials at the end feed. Let's say that it's a very simple material. It's the same material. It's always kind of the same shape and size. Maybe it's on a pallet. And we kind of know how it's going to work. So we've kind of drawn a box around this first simple use case. And if we look at it just at that level, it seems fairly straightforward. It feels like a point-to-point move where I'm just going to grab it from the warehouse, I'm going to take it to my manufacturing cell, and I'm done. So you're going to focus on just selecting the right AMR vendor to be able to move that material physically, and you may kind of stop your consideration at that point. But our challenge is to think about it at a deeper level. Think about how we're going to reduce the implementation cost, how we're going to reduce the cost over the long term. And remember, we talked about you want to automate as much of this process as possible. So if we take a deeper look at this process, most likely it's going to be more complex than what you see on the screen here. It's most likely going to look something like this. So when you talk about the automation, you've got to start the process. So how do we start the process? How do we trigger this process to happen? If you want to automate that, you may ask yourself, okay, what's the right way to do this? Well, this particular manufacturing cell has an MES solution. The MES has access to the bill of materials, it has access to the schedule. It knows when I need new materials. It knows what material it needs. That makes the most sense to be the start or the trigger for this process. Okay, so I've just added another system to my process that I need to integrate with, but it will add value because it can help automate the triggering of this mission. But let's say that you also recognize that it doesn't work all the time. There's changeover concerns, maybe increased scrap. There's conditions where I want to be able to manually trigger this mission as well. And I want the operator to be able to do that themselves. So I need to access my HMI, my operator station, I need to add functionality in for the trigger. So we've got a second step here and a second system that we need to communicate with. Now moving on, that material is in my warehouse, but it happens to be in a high bay storage rack. I've not automated that part of my process yet. I still need a human to jump on a reach truck, go into my narrow aisle storage, pull my load down and stage it for my AMR. That's a part of this process. Sometimes it's overlooked, but it's a very important part of this process, and we're trying to automate as much of this as possible. So if you think to yourself, how would this work ideally? Well, I have a WMS system. The WMS system has storage rules with it. It knows where this material is that I need. It knows ideally what location it wants to pick from to follow its rules. And it should be the thing that is now dispatching a mission to my reach truck driver. Well, I need some way to show my reach truck driver what he needs to get or she needs to get. So that could be a tablet interface on the reach truck. It could be an and-on board in the warehouse area. It could be some combination of the two. But in some way, you need some way, even though you're going to manually go get it, you want to automate as much of this as possible. So you may say, I want an HMI on my reach truck that dispatches that mission to that operator. He knows exactly where to go, where to pick from. And so he or she will jump on the reach truck, they'll go grab the product, they'll pull it down, and now I need to stage that for pickup for my AMR. Well, you're probably going to have a series of staging locations. Those are dynamic. And so that person is going to pick the one that either they see as most available, closest maybe, or maybe there's some rules that they're following. Regardless, when they drop it, it's time to call for the AMR. But I don't want to call the AMR until that time. You don't want the AMR sitting there while this person's going and getting the load. So at that point in time, we have to call for our AMR. The AMR has to come, it has to know what staging location I dropped that in. So the operator would have entered that manually, or maybe there's some automated way through sensors or a scanner that you wanted to do that. It can pick from there, and then it takes it the rest of the way out to your manufacturing cell. But let's say your job's not done right yet, because if you drop it on the floor, an operator's just going to have to grab a pallet jack to load it into like an in-feed conveyor. We ideally want to automate that as well. So in that particular case, your AMR is going to have the ability to interface with your conveyor, have a successful handoff, and that will complete the process. So if you kind of take a breath and step back and say, okay, now I've got this very complex, it looks very complex now, but ideally, if I can do the things I just mentioned, I'm helping to reduce the cost that's going to be associated with maintaining this thing. There's less human intervention. So we've got this kind of 8-step process. And what are some of the common threads that we got here? So number one is, we already talked about all these different systems that are involved. You need some sort of middleware that's connecting these things to be able to facilitate the communication between the systems. Another thing, we talked about this earlier, is there's control flow involved here. So there's a sequence in which things have to happen. Sometimes you don't want things downstream to happen until the thing before it happened. So you need something that's going to be able to oversee your whole process and be able to execute that control flow. And then the last thing is, there's this business logic that you're going to have to implement and execute in between all your steps, because there's decisions that have to be made based on exceptions that come up, things that happen that aren't foreseen, and you have to be able to program around that and hopefully get yourself out of it. So there's a lot of business logic involved here as well. All right, so the common theme here is, because you've got middleware that is connecting all these different systems together, if you now start to create a middleware product that can envelop this entire process together, it can start to be the thing that contains this control flow and this decision logic that you need in between all these steps, and it kind of brings everything together into a more unified, holistic solution. So if we go back to our S95 model here, and we start to expand or dream a little bit, middleware does more than just connecting one or two of these boxes together. It kind of becomes more like a connective tissue that can envelop all of your systems and processes and unifies everything together. So to wrap up here, we kind of want to hit on 3 core tenets if we're going to be able to reduce the cost of implementation and the cost of long-term support here. Number one, we've got to be able to integrate all of our systems together. That's a no-brainer. I think we all get that. But number two, it's got to be simple to implement and to use. It's got to be powerful because it has to be able to do all this advanced business logic we talked about, but you still want it to be simple enough that you don't have to have a computer engineering degree in order to be able to use it. It needs to work the way that you work. And you have to trust that when you make your configuration changes and you hit the save button, it's going to work that way. And then finally, if we've got one product that's sort of connecting all of our systems together from a middleware standpoint, you can start to optimize your whole solution. You got all your data flowing through one point. You can start to capture analytics, do logging. You can start to raise notifications and alarms and get people involved more quickly and optimize your solution as you're moving forward. And you pull all three of those things together, we've kind of hit the key point here, which is that we've got comprehensive orchestration. And that's kind of the word we like to use when we talk about the potential of middleware in this space, is that it's sort of a chaotic mess when it starts, but you need something to kind of bring all of that together to work together. So that's it. That's all I have for today.